Good morning, my dear students. Today I am going to teach you chemical change. This is chapter 4 of first paper. As it is your revision class, I would like to discuss about the creative questions, some important creative question of this chapter. Look at the whiteboard, my dear boys. The first one is given sulfur dioxide plus oxygen equals to sulfur trioxide. This is actually an exothermic reaction, because here if you consider the heat at the left side, it will be minus. Minus means heat is evolved from the reaction system. But to avoid the minus sign, I have written it at the right side. That's why this is plus heat. This is an exothermic reaction. And in the reaction number 2, nitrogen tetraoxide breaks to produce 2 molecules of nitrogen dioxide. Here the heat is absorbed actually. If you consider the heat at the left side, it will be plus heat. Heat is absorbed from the reaction system. So this is an endothermic reaction. At 25 degrees centigrade temperature and 1 temperature, nitrogen tetraoxide dissociates 25%. So find out the value of the Kp for the 2-nong reaction. My dear students, now I am going to show you the reaction number 2. Mole number at the initial state. As there is only nothing is given here, so it will be 1 mole. 1 mole, and at the initial state there is no product. That's why I have written here 0. But mole number at the equilibrium state, as the let the dissociation degree of dissociation of nitrogen tetraoxide is alpha, so the remaining mole number at the equilibrium state of nitrogen tetraoxide is 1 minus alpha mole, and as there are 2 moles, that's why it will be 2 alpha mole. And the total mole number at the equilibrium state, total mole number at the equilibrium state is equal to 1 minus alpha plus 2 alpha equals to 1 plus alpha. So now I have to calculate the value of partial pressure of both of the nitrogen tetraoxide and nitrogen dioxide. Partial pressure of nitrogen tetraoxide P(N2O4) equals to, all of you know that partial pressure equals to mole fraction into total pressure. Let the total pressure is P, so mole fraction equals to mole number of nitrogen tetraoxide is 1 minus alpha divided by total mole number. All of you know that mole fraction means mole number of respective substance divided by total mole number of the system, is known as mole fraction into total pressure. Let the total pressure P. My dear students, it is noted that this P is actually capital P, which denotes the total pressure, but this P stands for partial pressure. This is actually small p. And in the question it is given degree of dissociation or rate of dissociation, alpha equals to 25%. 25 divided by 100 for percentage, it will be 0.25. So the result will be 1 minus 0.25 divided by 1 plus 0.25 into total pressure. The total pressure is given and the question 1 atm pressure. So the bill will be 0.6 atm, 0.6 atm, and again partial pressure of the nitrogen dioxide, partial pressure of the nitrogen dioxide PnO2 equals to mole number of nitrogen dioxide at the equilibrium is 2 alpha plus total mole number of the system is at the equilibrium 1 plus alpha into P. So 2 into 0.25, 1 plus 0.25 into 1 atm, I mean total pressure of the system is 1 atm, equals to 0.4 atm. 0.4 atm. My dear students, we know that equilibrium constant Kp equals to partial pressure of the product P product, coefficient will be the power divided by partial pressure of the reactant, equals to 0.4 square divided by 0.6 atm. This is atm. So the value of Kp will be 0.2667 atm. Okay, my dear students. Question on D. If temperature is increased, then in which reaction of the stem maximum product is obtained? I mean reaction 1 and 2. First you have to write reaction 1 and 2, then you have to mention reaction 1 is actually exothermic reaction. Exothermic reaction, and reaction 2 is endothermic reaction. Reaction 2 is endothermic reaction. My dear students, all of you know that in case of endothermic reaction, if we increase the temperature, the equilibrium will shift to forward to produce more product. So in the reaction on 2, if we increase the temperature, more product, I mean more nitrogen dioxide is produced. Actually, according to the Lachazelli's principle, if any of the factor of the equilibrium reaction, like temperature, pressure of concentration of the reactant is changed, then the equilibrium of the reaction is changed, is shifted in such a way, to relieve the change, to relieve the stress for the changing of factor. This is the actually Lachazelli's principle. And if we increase temperature, equilibrium of the 2-nong reaction shifts to forward to absorb the change of heat, and actually when the equilibrium will shift to forward, more nitrogen dioxide is produced. So I can say in case of reaction 2, if we increase the temperature, more product or maximum product is obtained. That's all about the a creative question of this is a very important creative question for you, my dear students. Now I will discuss another creative question. My dear students, find out the value of Kp for the reaction of the stem. The reaction of the stem A2 gas plus B2 gas, reversible sign, product AB3, it is given in the stem AB3. So this is the balanced reaction, and according to the stem, at the equilibrium mixture, at the equilibrium mixture 25% AB3 is produced. It means hence from 25 mole AB3 exits in 100 mole equilibrium mixture. Equilibrium mixture. Here actually the ratio of the A2 to B2 equals to 1:3. Here 1 mole and here 3 mole. And the sum of ratio terms equals to 1 plus 3 equals to 4. So mole number of A2 equals to AB3 exists in 100 mole equilibrium mixture. So remain amount is actually reactant, my dear students. The remain I didn't mention here. Remaining A2 and B2 is 100 minus 25 equals to mole, equals to 75 mole. So mole number of A2 equals to 75 into, as this is A, the ratio term of for A is 1 and the sum of ratio terms is 4. So it is 18.75 mole. And mole number of B2 equals to 75 into for B the term is 3, so it will be 3 divided by 4, sum of the ratio terms 4, so it will be 56.25 mole. So my dear students, the partial pressure of AB3. AB3 equals to AB, mole number of AB3 25 mole. 25 mole divided by total mole number of the equilibrium mixture 100 into total pressure 50 atm. It is given in this chart. 50 atm equals to 12.5 atm. So the partial pressure of AB3 goes to 12.5 atm. Partial pressure of A2 equals to mole number of A2 equals to 18.75 divided by total mole number of the equilibrium mixture is 100 mole into total pressure of the reaction system is 50 atm. So the result is 9.375 atm. Partial pressure PB2 equals to mole number of B 56.25 divided by total mole number 100 into total pressure 50 equals to 28.125 atm. And we know that equilibrium constant for partial pressure Kp equals to partial pressure of product. Here product is AB3, PAB3, and the coefficient of product is 2 divided by partial pressure of reactant A2 into partial pressure of P2 and the coefficient is 3. That's why I have to write here 3 and then put the values of partial pressures of products. Partial pressure of AB3 is 12.5 square and partial pressure of A2 equals to 9.375 into partial pressure PB2 is to 28.125 cubed. So Kp equals to 7.491 into 10 to the power minus 4 atm inverse 2. That's all about the value of Kp. My dear students, the reaction of the stem is A2 plus B2 gas, reversible sign AB3. It is written according to the stem. And here delta H value is minus 92 kilojoule, as 92 kilojoule heat is evolved in this reaction according to the stem. And to produce maximum AB3 by the application of Le Chatelier principle, first if we observe the reaction, we get some points. This is an exothermic reaction, as the value of delta H is negative, and the volume decreases in this reaction because there are 1 plus 3, 4 volumes of reactants, but after reaction it becomes a 2 volume. The reaction is a reversible reaction. This reaction occurs forward and simultaneously backward reaction also occur. And to produce maximum AB3, I have to apply optimum temperature. The reaction is an exothermic reaction. So if we increase the temperature, equilibrium shifts to backward. So to produce more AB3, I have to decrease the temperature, but at low temperature, the rate of reaction becomes slow. This is a contradictory state. This is a contradictory matter. That's why in this state, an optimum temperature is used to produce maximum AB3. Maximum production of AB3. Here, an appropriate catalyst is used, and in some cases, catalyst promoter is also used to increase the catalysis ability of catalyst. And high pressure, if we observe the volume of the reactants, there are 4 volumes of reactants. Total volume of reactants is 4 and the total volume of product is 1. So if we increase temperature increase pressure according to the Le Chatelier's principle, equilibrium shifts to forward. In this case, an appropriate pressure is applied to produce maximum AB3, and after producing maximum AB3, it will break to produce AA2 and B2 again. I mean backward reaction will occur again. To stop the backward reaction, I have to collect the AB3 from the reaction system. Then we can get maximum AB3 by the application of Le Chatelier's principle. My dear students, that's all about the those two creative questions. Those two type of creative questions are very important for all of you, and goodbye.